So just a quick recap of what we were discussing in the previous session. So in our previous session, we're looking at analytical tools that we use in business, or we're looking at forecasting tools that we can use to predict what is likely to take place in the future. So what is likely to take place in the future? 0.1. So if you are predicting what is to take place in the future, we did look at the simple average growth model, which is used to predict the growth rate or to estimate the growth rate. We also did mention the high-low method. The high-low method is used if you want to determine the variable cost that we also then substitute into our total cost function. So once we have the total cost function, it can be used to predict the future. Then besides the high-low method, we also did talk about the time series analysis. So the time series analysis looks at the change over time. So there can be a trend, an upward or a downward trend. The changes can be as a result of seasonal variations, as a result of changes in business cycle, as a result of random variables. Then also, we did talk about the learning theory. So under the learning theory, this is used to predict the labor that, this is normally used if we want to estimate the amount of labor. This is used when we are estimating the amount of labor. So under the learning theory, the basis of this theory is that the more someone keeps repeating a task, then they end up taking less time. So if you repeat a task over and over, and if this task is not being carried out by machines, humans, they enjoy the learning effect. So you end up taking less time, but this task must be a complicated task, and it must be performed repetitively. So we did look at some of the factors that we need to consider for us to have what we call the learning effect. So we did talk about the learning effect and the factors that influence the learning effect. Then besides the learning effect, we also did talk about calculating the learning rate. We did also talk about calculating the learning rate. That was the last thing we discussed. So let me start from there. Then maybe we look at regression and correlation. Then we move to standard costing. So before we move to regression and correlation, we have to add the issue of what we call a steady state. We can have what we call a steady state. So a steady state, what is this state? This is where the learning effect is no longer being enjoyed. So you learn up to a certain number of units. So yes, you enjoy the learning effect, but there is a point where we get to where the learning effect ceases to apply. At that point, we are said to have reached the steady state. So even if you keep producing more units, you will not, maybe the time that you're taking per unit will not reduce, because under the learning effect, the more you repeat the same task, you end up taking less time. So for each additional unit, the time that you're taking will be reduced. But if you reach the steady state, it means after this state, extra units will not, also after this state, if you increase the amount of units, the time that you'll be taking will be the same. So let's maybe say this is the level of units. From which the learning effect ceases to apply. This is the this is the level of units from which the learning effect ceases to apply. All extra units will not reduce, will not be produced at less time, will not be produced in less time. So we are saying if the steady state is reached after producing 100 units, let's say you reach the steady state after producing 100 units. It means for extra units, that is for 101 units, or if we are to go to 105, all those units, they'll be taking the same time that the 100th unit took. So from the first unit up to 100 units, each unit will be taking less time. But after reaching the 100th unit, it means all the additional units will not be taking less time. So let's say, can I please have if the learning, we can say if the steady state is reached after 100 units. This means that the time per unit will be reducing for each additional unit, from the first unit. So each additional unit, time per unit will be reducing from the first unit and up to 100 units. All units produced after 100 units, all units produced after 100 units will then take the same time as the 100th unit. Will then take the same time as the 100th unit. So let's have a question. Example. The time taken to produce the first unit is 20 hours. The time taken to produce the first unit is 20 hours. The learning effect is assumed to be at 90%. And the steady state is reached after producing. The steady state is reached after producing 50 units. What is the budgeted time for 70 units? 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 Taking into account the learning effect. So the learning effect is actually used to predict the amount of labor we are going to use up or the time that we are going to need. So we are told that the first unit is taking 20 hours. Then we are going to be enjoying a 90% learning effect. Then after 50 units, the learning effect stops or we reach a steady state. So for the additional units after the 50th unit, we won't be enjoying the learning effect. So how do you determine the time for the 7th unit? The first thing is to calculate how much time is needed for the first 50 units where we are enjoying the learning effect. So we need first the total time for the first 50 units. For the first 50 units, where we are enjoying the learning effect. So we need the total time for the first 50 units, where we'll be enjoying the learning effect. So for the total time for the first 50 units, how do you come up with this? Remember, I gave you a formula last time. I said if you're calculating the total time, you use the formula y is equals to ax to the power b. This will give you the average time per unit. But if we need the total, we then multiply by the number of units. So let's do it together. So the formula we are going to use is y is equals to ax to the power b. Ax to the power b, where a, we say it is what? Time for the first unit. So for the first unit, we need 20 hours. Yes, sir. X is the number of units. In this case, we want the total time for 50 units. So our X will be 50. So X is the unit to say, we are saying is the total, is the average time. Firstly, we find Y, which is the average time. Then the total, you then multiply by 50. So is the average time after 50 units. So X will be 50. Then B, we said B, you say log of rate over log of R. Log of rate over log of 2, sorry. B, we said log rate over log 2. So what's the value for B? 0.152. So now we have the variables. Let's substitute in the formula. What do you get your Y as? 11.035. So this is the average time per unit. So Y is the average time per unit, but we want the total time for 50 units. On average, each unit is taking 11.035. So for the 50 units, would then say 50 times 11.035. So that's for the 50 units. So 50 times 11.035. What do you get? This is the total time that we need to produce 50 units. But the question is saying, what is the time needed for producing 70 units? But our learning effect is up to 50 units. So you first calculate the total time up to the last unit where we are enjoying the learning effect. Now we want, if the learning effect is ending at 50 units, so it means the 51th unit is taking the same time with the 50th unit. So 51, 52, 53, they are all taking the same time that the last unit took. So we need the time needed to produce the last unit, or the time for the 50th unit. Time for the 50th. We need the time for the 50th unit. There is the average time, first later the time for the 50th unit. We said to get the time for the 50th unit, you say T50 minus T49. Time for the 50th unit minus time for the 48th 9. Like here, we say time for the 16th unit, you say T16 minus T15. So here we need the time that the 50th unit took. Not the average time for all the units, but the time for the 50th unit. That is the same time that all the other additional units will take. So the time for 50 units, we got it already. It's 551.77. What about T49? What about the total time for 49 units? So you take you first of all work out the average time, then you multiply by 49. $542.38. $542.38. So what's the time for the 50th unit? You then say 551.77 minus 542.38. So it means the 50th unit, to produce the 50th unit, is taking 9.39. So what is the difference with this 11.035? 11.035 is the average. We are saying we have produced the 50 units, but what is the average time per unit from the first unit? But this one is just calculating the time that we took to produce the 50th unit. So this one, Y is the average, but the 9.39 is the actual time that we took to produce the 50th unit. Because for the average, it means you're adding the time for the first, the second, up to the 50th unit, then you average. But for this one, we are looking at what is the time needed to produce the 50th unit, not the average. So after the steady state, all the additional units will be taking the same time. So we are saying up to 50 units. So up to 50 units, the total time that we took after applying the learning effect, this is 551.77. Then the additional units to get to 70, how many units do we need? 20. So the additional 20 units are all going to be taking the same time as the 50th unit. So the additional units will take the same time as the 50th unit. They will take the same time as the 50th unit. So it means in total, for 70 units, after applying the learning effect, we are budgeting that the 70 units would take us 739 hours. So if they say we are budgeting labor and there is learning, there is the issue of the learning effect. It's not just a matter of saying the first unit is taking 20. So for 70 units, it's 20 times 70. No. So if we had said 20 times 70, what would be the answer? So it would be 20 times 70, it would be 1.4. But because of the learning effect, the time that we take for the first unit is not the same for all the other units. So if we budget not incorporating the learning effect, you are likely to come up with an over budget. You are likely to over budget. It means you put a budget that is too easy to achieve, because the workers, it means they will have extra time. Because we are going to say they need 1.4, we pay them for 1.4, but they will actually take 739 hours. So that is on the learning effect. Now, the other issue is correlation, regression, and correlation. So regression and correlation. So the correlation looks at, we have two variables that we want to see if these variables are somehow connected or not. So there is need to determine, is there a relationship between these two variables? So you can say this measures the strength. This measures the strength of the relationship between two variables. So I want to see the relationship between two variables. Are they related? So we can have a case where there is no correlation. It means there is no relationship. So if there is no correlation, it means there is no relationship. It means the variables are not related. So if there is no correlation, the variables are not related. Then we also have a case where there is a positive correlation. A positive correlation, it means if you increase one, the other also increases. Like if you are to look at a case of the price and supply. Suppliers are willing to offer more goods at a higher price. So the more you increase the price, the more the amount of goods that they want to supply. So there's a positive correlation. So positive correlation, that's the other correlation that we have. Positive correlation. It means if you increase one, the other also increases. Can I take that? Hello, sir. All right. The bottom lesson, okay, but Lanchite graduate business management saka dziri kuitwa Wednesday 6 dziri kuitwa 6 to 8 saka menoti schedule yako can you reschedule or nongo saka it's fine. I'll send you in. So positive correlation, it means if you increase one, the other also increases. Then besides positive correlation, we have negative correlation. So the negative correlation, this would be the case of demand. And if we are to look at the case of demand and price, so you realize that when prices are low, demand is likely to be high. But once you increase prices, demand is also going to fall. So there is a negative relationship. There is a negative relationship. So you can say there's a negative correlation. So if you are to draw a line, positive correlation, it would be a straight line slanting upwards. Negative, it will be slanting downwards. So the correlation is denoted by R. So instead of U, in most cases, to determine the correlation, we make use of, to determine the correlation, we make use of an equation for R, which I believe this would be given in the, let me just check for an equation paper. So R is the correlation. That's how you use R to determine the correlation. So this can range from -1 to 1. So -1, if you calculate your R and it's -1, it means there is a perfect negative correlation. If it's 1, there is a perfect positive correlation. Then 0, there is no correlation. Then the closer we get to 1, the closer we get to it's positive correlation. So if it's above 1 but closer to 1, so it's above 0 but closer to 1, that's positive correlation. Then closer to -1, it would be a negative correlation. So let me check for the formula for R that we use. Unfortunately, I thought I could get it on this one. So, okay, so here is the formula for the learning curve, the formula for the demand. I think this was an old question. Anyway, for the sake of time, let's just move. I will send you the formula for calculating R, but it's there on the, or let me use the practice platform. Let me go to, not the practice platform, but I think let's use the study hub. Okay, so now let's look at, this is your study hub. Analytical tools, correlation. Okay, so we have a positive correlation, negative correlation, zero correlation, perfect correlation. So perfect, it can be perfectly negative or it can be positive. So that's R. So this is the equation for calculating R. So it's a very long equation that I would want you can maybe memorize. There's no need really to memorize, but you need to apply it. So through, I think this one in the exam, it will be given, so there is no need for you to cramp that. So that one is the equation that you use to determine whether there is a perfect correlation or whether there is no relationship, whether there is a strong positive correlation or there is a strong negative correlation. So I think the interpretation is given here as well. Positive one is positive correlation. Negative one means perfect negative. Zero means uncorrelated. Then there's a table here that they've given for the example, but I would prefer if you are well versed with your calculator, if you have a sharp calculator, you can just punch in these figures in the calculator. So instead of doing this table, let me just have maybe, or we can have these figures down. Let's just take the X and the Y. Then we feed them in the calculator. Instead of going through all these calculations, you can just feed these figures in the calculator, then you can get the summation of n is equals to 5, summation of x is equals to. So you can get all these variables on your calculator, especially if you're using the sharp dial calculator. That's the simplest one to use. So maybe we can try that. You have, oh, you have that one. And also, maybe for those that are joining online, did anyone do Maths A level? You did. Okay, for those joining online.
No.
No.
Is.
Okay.
No.
So for feeding the data in the calculator, if you are feeding the data in the calculator, let me just give you the steps. So I wouldn't want us to waste much time on this. So I'll just do a quick demo. Then if you have a challenge with this, I can assist you individually. So you just send me, you just notify me so that at least it doesn't distract others as well. So there's 14, 27, 20, 22, 17. So let's go and put that on our Excel. So we'll be given the X variable and the Y variable. So we have X and we have Y. So there was 14, 27. What's next? 20, 20, 22, and 17. Can you also get the Y variables? Just jot down the Y. Okay, so let's go and put our Y variables. We have 59, 102, 84, 85, 75. So using, if you're using the sharp dial calculator, the first step is to go to the states mode. So you press the mode button, then you go to states. So that's mode, then you go to states. So it's mode, you go to states, then that states, it will be state, it will give you, if you say mode, then you press 1, it will go to states, then it will ask you whether it's line, SD, or quad. So you can press line, that's 1. So it will display states 1. So once it is displayed states 1, it's now in the statistics mode. It's now in the statistics mode. So in the states mode, you can enter the first variable, 14. Then there's a comma. So you say 14, then you say, if you go to the store button there's a comma, then you put the Y variable, which is 59. So it's 14, then the Y variable, which is 59. Then you say M plus, it will give you a notification that you have entered the first set of data. Then you do the same, you just go to the next variable, 27, you press the comma on the store button, then you press the second variable, 102, then you press M plus, it will say data plus 2, data set 2. So you do that until you reach the end. So for those that have not done this before, don't worry, you can let me know, I'll assist you afterwards. So you just do that until you complete inputting all the data that you have. So after you have input all the data that you have, we can then easily come up with the variables that the question is asking. Because if you have input the data, if you are using that old sharp dial calculator, it has these summation of, let's go back to the formula. Let's go back to the formula. You can see all these are on the formula. The n, the summation of x, are there on the calculator in blue, or it could be in green. So the summation of x is there, the summation of x squared is there, summation of ex squared, summation of y squared. So it's just a matter of then saying second function, you press where the summation is given. For example, if you want summation of ex squared, just say second function, then you press summation of ex squared is on the plus or minus button. So I think let's do this task later on. For now, just master the formula. So having the formula for R is given in the question, is given actually on the formula tab. So there is no need to claim that. So it's just you being able to input the variables. It's just you being able to input the variables. So I want you to try to attempt substituting these variables. Then I will be assisting you so that at least we don't delay much on this area. So after you've obtained the value for R, if you square that R, you get what we call the coefficient of determination. So the coefficient of determination is looking at is the model you have used suitable? It's more like it measures the suitability of the model. So we are trying to find the relationship between the two variables. So the coefficient of determination, it looks at the suitability of the model that you are using. So this one is always positive. So it ranges from 0 to 1. It's a percentage. So if it's maybe 90%, it means the model you have used is very suitable for estimation, because you want to estimate and you want to look at the relationship between two variables. But is the model that suitable? If the coefficient of determination is high, it means the model is appropriate. But if it's low, it means the model is not that much appropriate. So how do you get the coefficient of determination? You first of all get your R, then you square that R that you have obtained. So the square of that R, that gives you the coefficient of determination. Then now let's go to regression. So the problem with correlation, it just measures the relationship between two variables, but it's not that useful in predicting the next outcome. It can show us that there is a relationship. There's a strong positive relationship. There's a strong negative relationship, but it's not the best for determining what is the possible outcome in the future. So if we want to predict what is going to take place, we can make use of a regression. So we can say correlation shows the strength of the relationship. Correlation shows the strength of the relationship. But it's not a useful measure when estimating, when making predictions. So when we want to make my predictions, regression and correlation is not the best measure to use. So for making predictions, what then can we make use of? So if we are making predictions, we then make use of regression. So for making predictions, we can use regression. For making predictions, you can make use of regression. For making predictions, you can make use of regression. So for regression, it uses the equation y is equals to a plus bx. Where in most cases, y could be what we want to predict, the cost that we want to predict. So y is the cost that we would want to predict. Then the A and the B we have to calculate. The A and the B we have to calculate. If these are costs and units, X is the number of units. So for you to get the regression, there's what we call the regression equation. That is y is equals to a plus bx. We are supposed to find the value of a and the value of b and substitute into the equation. So A and B are constants or are numbers. A and B are constants. We have to determine the value of A and B. A and B are constants. We have to determine the value of A and B. So the final equation or the final regression equation is supposed to be like, let's say if we have calculated our A to be, if we calculate our A to be, let's say 12, and our B to be, if we calculate our A and we get 12 and our B 0.12, then our regression equation would be y is equals to 12 plus 0.12 x. So we then use this equation to predict the future costs by saying because remember x is the number of units. So you just change where we have x and put number of units. We want to predict, let's say, the cost for 100 units. You just substitute for x, you put 100. But how do you come up with A and B? A and B, again, there is a formula that you have to use, which is given as well. So this, if you can look at the formula there, that's the formula for A. And that's the formula for B. So these ones will be given in the exam, but you need to practice making use of these formulas. So the first thing is to calculate B, because to calculate A, you need B. On the formula for A, there is B. So you first of all work out B, then you work out A. But when you're calculating A, you make use of the B that you've calculated. Okay, so for these models, the regression, especially regression and correlation, the first thing that you need to go and master is to try to feed the data in the calculator that you are going to use in the exam. Please practice using the calculator you are going to use in the exam, because these calculators, they are different. But if you cannot, or if you are facing challenges using the statistics mode, you can make use of the table, like the example that they've given us, but it's a bit long, but it's also another optional way of doing it. So practice makes perfect. So you can first of all go and try using the formulas A and B, go and try that. Then if you face challenges with either substituting in the formula or getting any of the variables, you can then come back. But because of my time, I have to move to the next thing. So the next thing that we have to introduce is standard costing. Time is not on our side, so standard costing, which is a new topic. So let's start with a standard cost. If you hear someone talking about a standard cost, what is a standard cost? A standard cost is a budgeted cost per unit. So a standard cost is a budgeted cost per unit. The standard cost is a budgeted cost per unit. The standard cost is a budgeted cost per unit. So how do you come up with this standard to say, okay, my budget per unit is $5, my budget per unit is $10. How do you come up with this budget per unit? So there are different types of standards that can be set. So if the standard has been set as a basic standard, so we have the first one, the basic standard. This is a standard which remains unchanged for a long period. So you are just using what we know. You are not creating something for your own. You're just saying, okay, this is what is known. This is what has been taking place over the last 10 years. So that is the standard. You're just using something that has been existing for a long time. You're coming up with a standard based on what has been existing. Then we can have an ideal standard. If a standard is set as an ideal standard, this is a standard which assumes perfect operations. So it assumes perfect operations. So if we are setting a standard, we can say, okay, can you want to produce, then you say, can you produce one item, let's see. Then you can, maybe you realize that they are able to produce one item in an hour. Then we say, since you're working for 6 hours, every day we want 6 units. So that standard did not give an allowance that this person will need bread, this person will need lunch. So it has been set assuming perfect operations, assuming this person is not going to rest, is not going to go for lunch, is not going to have any disturbance. So that's an ideal standard. The problem with this type of a standard, it tends to demotivate because it's not easy to achieve. If a standard has been set, assuming perfect operations, it means there is no break for you. But it tends to push workers to their limits. It makes sure that every worker is working hard because there is no room for rest. So besides an ideal standard, we have an attainable standard. We have an attainable standard. So an attainable standard, we are looking at something that people can achieve. So it incorporates slack. When you're setting this standard, we also take into account that there can be disturbances. So this standard incorporates slack or idle time. So we also give room that someone might need a break, someone might need to go for lunch. So that's if it's an attainable standard. So the good part about an attainable standard, it tends to motivate because the standard is set based on something that is realistic. So it is based on something that is realistic. Let's move on. Then we can have a current standard. That's the last one, current standard. The current standard. So if it's a current standard, this one is normally a short-term standard. This is a standard used for a short period of time. This standard is set for a short time frame. Could be based on the current operations. So just setting a standard for a short time, it could be based on what is taking place currently. So the standard is just based on what is currently taking place. We set a target based on what is currently taking place. So these are some of the method or ways we can use to come up with a standard or a target that we want to achieve. So the standard is or we can say it's predetermined. This is before the actual production. So we come up with a standard before the actual cost. If it's a standard cost, it's before the actual cost. We then compare the standard with the actual. So we then later compare the standard with the actual. If there is a difference, then there is a problem. So the standard is compared with the actual, and the difference is a variance. So when there is a difference, between the standard and the actual results, we call this a variance. So the difference between the standard and the actual results, we call it a variance. The variance can be in two. So if it's a good variance, because in most cases, in some cases, it could be good, it can be bad. So if it's a good variance, I'm sure you know that one is a favorable variance. So if it's a good variance, it's a favorable variance. If it's bad, it's an adverse variance. So these variances, we can calculate the variances for material, we can calculate the variances for labor, for overheads, for sales. So the variances can either be income variances. If we're looking at variances like for sales, they are income variances. Under income variances, we actually prefer that the actual results are more than budgeted. Let's think of sales. It's actually good if you sell more than what you were budgeting. But if if you spent more than budget, it's something bad. So income variances oppose cost variances. income variances oppose cost variances. For income variances, more is better. For income variances, if the actual results exceed the budget, it is favorable. Then the opposite is true for cost variance. So for income variances, it's actually good to spend, to have more than budget, more sales than budget, a higher selling price than budget. It's something that is actually good. Then the variances can be classified in two categories. We have basic variances, which I believe you have done this in management accounting. I'll just revise some of the key that we need to, because for F5, they are going to focus on the advanced variances. So we just recap the basic variances, then we move to the advanced variances. So for the variances, we have the basic variances, that is, we have material price variance, material price, we can say material variances. We have the labor variances. Then we have the sales variances. So we need to know the basic variances so that we can be able to expand them to the advanced variances. So the advanced variances for material variances are advanced to, we'll talk about the material mix and the material yield. So it is the material variances which we further advance to material mix and yield. So with the material mix and material yield, for all these material, labor, and sales, we are also going to talk about the planning and operational variances. For all these, we are going to talk about planning and operational variances. So those are the new variances we are going to talk about. So let's start with the basic variances before we advance them. So the basic variances, we'll start with, just have a quick recap of the basic variances. So for the basic variances, let's start with the material. So material is part of the cost variances, and we have the material price variance being the first one, material price variance. So under also the advanced, I left out, we have the sales mix, and so for the sales, we have the sales mix and sales quantity variance. So for the material variances, we can start with the material price variance. So this variance looks at the difference between the price we were targeting in the market against the actual price that we paid. So this compares the budgeted price of material per kg, or we can say per unit, against the actual price. The unit could be the kg, it could be the meters, depending on what are we looking at. So how much were we budgeting against what we ended up paying. So that is the material price. So that's the material price. So besides in fact, the formula for the material price so the material price would say that's the standard price minus the actual price times the actual quantity. The standard and the actual price are per unit, but the actual quantity is in total. Then besides the material price, remember this is just a recap. We're not going into detail for this. We have material usage variance. So for the usage variance, this is looking at the quantity that we were expecting to use against what we ended up using. So this compares the budgeted quantity for the units produced against the actual quantity. This one is a bit tricky. Why? Is the budgeted quantity for the units produced. Take note of this. Is the budgeted for the units produced. Meaning what? Sometimes we can budget to use 20 kgs, but, or let's say we can budget to use 200 kgs, but this is being budgeted for 4,000 units. So if we ended up using 250 kgs for 5,000 units, we don't jump into the conclusion that we are not doing well. Why? Because the 200 kgs, or we don't just say we did badly, we used more than budgeted. Why? The 200 we budgeted was for 4,000 units. So if you are comparing, you have to say, I was budgeting 200 for 4,000 units. But what would be the same budget if I had used the 5,000 units? So that is the budget for the actual units produced. You can just use even proportion to say 200 was for 4,000 units. But what would have been my budget if I had budgeted for 5,000 units? Or you can say the 4,000 units, the 200 is for 4,000 units. So what's the budget per unit? So you'd say 200 over 4,000. Then you get that. So your budget for each unit was 0.05. So it means for 5,000 units, what would be your budget? You would say the budget per unit times the units you produced, 250. So it means in this case, there isn't any variance. What we were budgeting is what we actually used. The difference was as a result of the units. So when you are comparing the budget, there is need to also consider the units produced. So for material usage variance, this compares the budgeted quantity for the units produced against the actual quantity. So the good thing would be to use less material than budgeted. The formula, it says that the standard quantity for actual units, this is the budget for the actual units, minus the actual quantity used times the standard prices. So that's the material usage variance. We are comparing the material we actually used against the budget. Then from the material usage, let's go to the labor. So for labor, it's the same thing, only that for labor, we don't call it price, we charge labor at a certain rate. So we have labor rate variance. So the labor rate variance, this compares how much were we planning to pay for labor against what we actually paid. So this compares the budgeted price for labor with the actual price. So what was the budgeted rate per hour against what we ended up paying? What was the budgeted rate per hour against what we ended up paying? So the labor rate variance. This compares the budgeted price for labor with the actual price. Then the formula is similar to the material price variance, only that we are replacing the price with the rate, the quantity with the hours. Please take note of these formulas because as we move to the advanced variances, these formulas you might need to make use of them. So for labor rate variance, you say the standard rate minus the actual rate times actual hours. Standard rate minus the actual rate times the standard hours. So it's just comparing how much were we planning to be charged for labor against what we ended up being charged. Then besides the labor rate variance, we can also have the labor efficiency variance. The labor efficiency variance. So the labor efficiency variance, this compares the budgeted hours. This compares the budgeted hours of labor against the actual hours. This compares the budgeted hours of labor against the actual hours. So trikutima hours atangatida for the actual units produced. Say that data server material is the budgeted hours for the actual units produced. So it's not just the budgeted, but it's the budgeted for the actual units, less the actual hours times the standard rate. So that is, if we look at the material price, material usage, labor rate, labor efficiency. Now let's move on. Let's move on to the sales. So for the sales now, they oppose the cost variance. So we start with the sales price variance. The sales price variance. So for the sales price variance, we are saying we start with the actual. So we're comparing the actual price with the budgeted price. So it's the actual price minus the standard price times the actual volume. So for the sales price variance, it's comparing the price we wanted to charge against the price we actually charge. So this compares the price we wanted to charge against the actual price charged. Then we have the sales volume variance. Sales volume variance. This one, it's in two. We can have the sales volume profit variance or sales volume contribution variance. So it could be the sales volume contribution So for the sales volume contribution variance, the formula is the actual volume minus the standard volume times the contribution per unit. It's the standard contribution per unit. Given the actual, you use the standard contribution per unit. So it's the actual volume minus the standard volume times the standard, so the actual volume minus standard volume times the standard contribution per unit. Then we have the sales volume profit variance. Sales volume So for the sales volume profit variance is the actual volume minus the standard volume times the standard profit. So they can say that the company is using an absorption costing system. They will not tell you, they'll just calculate the sales volume variance. Then they'll say the company uses a marginal costing system or it uses an absorption costing system. So the marginal costing system is the one that makes use of contribution. So marginal costing uses contribution, but absorption costing uses profit. So if it's absorption costing, it uses profit. These were the basic variances. It's less likely that you get a basic variance question So If we get a basic variance question, it would be rare or it will come together with a question on advanced variances. Now, let's not waste much time on the basic variances, but get to the advanced variances. So the advanced variances are the key. Those are likely to be asked for FR. So advanced variances. So for advanced variances, for our advanced variances, just a moment. Hello. Masomo zote chinoona ngechiri kuitika. Mampa namba yepa alright yekuti alright. Daimandoti iye acho ngaambotry because muchindawo chesecurity ivo ngawatry kuzobatidza vega because zuva handiningira. Alright. So advanced variances. Advanced variances. So for advanced variances, we can start with advanced variances for material. Advanced variances for material. So for material, we have the material usage variance. For material, we have the material usage variance. The material usage variance is further broken down into two variances, which are the material mix and the material yield. So the material variance is broken into material mix and material yield. What is the material mix variance? So for the material mix variance, we are saying that for the material mix variance, we are saying the product that we are producing uses different components. So for us to calculate the material mix variance, it should be we are producing a product which uses different components. So let's think of a cake. We need flour, we need cake, we need flour, we need sugar, maybe we need we can need the essence, we might need the eggs. So these are the different ingredients that we use when we are baking the cake. So the material mix then says, if you change the ratio, we are still producing the same cake, but we change the ratio in which we were mixing the inputs. is it going to become cheaper or more expensive? So we are going to change the normal ratio. So we compare what was the standard ratio and the new ratio. Then you compare to see whether the new ratio is now cheaper or more expensive. That is the material mix. So this compares the new mix ratio with the old ratio in order to see whether the new ratio is cheaper or more expensive. So we are comparing the new and the old ratio in order to tell whether the new ratio is cheaper or more expensive. So the material mix variance. Hello, Bobo. It's okay. Message down on the bottom lessons. It's fine. Okay, so sorry, let's move. So the material mix variance, this looks at whether the ratio we are now using is cheaper or more expensive. So we are going to use a table to determine whether, to come up with our material mix variance. So the table starts with the components, that is what we are mixing. So it starts with the components that we are mixing. So besides the components, we have the actual quantity. I'll just use abbreviations, but you can write in full. It's actual quantity, standard mix, actual quantity, actual mix. Or maybe let's write them here. So actual quantity, standard mix. This means the actual quantity at the standard mix ratio. This means the actual quantity in standard mix proportion. This means the actual quantity in standard mix proportion. Then the actual quantity, actual mix. This means the actual quantity. This means the actual quantity in this actual the actual quantity at the actual mix ratio. So these are the quantities we used using the current ratio, not using the budgeted ratio. And so the actual quantity at actual mix. Then you say actual quantity standard mix less actual quantity actual mix, you get your variance, you get your difference. Then from the difference, you put the standard price, then the variance. So that's the table we're going to be using: component, actual quantity, actual mix, difference, then variance. Let's look at an example. We may look for an example that we can do together. Let's look at this testing your understanding 8. Calculate the material mix variance. Calculate the material mix variance. So can you take a pic or memorize the amount so that we transfer them to Excel? So let's go and apply that to the question, sorry, to our performer. So we need the components. The components. Actual quantities, standard mix. Actual quantity, actual mix. Difference. standard price, variance. So the components, the actual quantity, standard mix, actual quantity, actual mix, the difference, the standard price, the variance. So for the components, on our question, which components do we have? A, B, and C. So we have component A, we have component B, and we have C. So we start with the second column. We skip the actual quantity standard mix column. Let's skip it and we move to the actual quantity, actual mix. So actual quantity, actual mix, we are saying for the actual units that we used, how many quantities of A were used, how much of the quantities for B were used, and how much for C. So you're looking at the actual results, not 14,000, right? We are looking at the bottom for those that did not manage to take a pic, kindly take the pictures. So we are looking at this lower table. Why? This is the actual materials used. So that's what we want. For A, for B, for C, 14, the 5.5, and the 5.5. So these are the actual quantities. It's the actual ratios or actual mix. So for A, we had 14,000. For B, it's 5.5. For C, 5.5. Then the actual quantity at standard mix, we are saying for the material that was used, if we were to share it in the standard mix ratio, how would we share? So in total, we have used 25,000 of the material, but being shared in this proportion. What if we had used the standard mix? So you're taking the actual quantity in total. We share this 25,000 using the standard mix proportions. The standard mix proportions, where do you get them on the question? The standard mix proportions are here. So we were planning that for 1,000 units, we would use 600, 240, and 360. So this is the ratio. You can use 600, 240, 360. So if you are sharing in the ratio 600 is to 240 is to 360, you can reduce that. That 60 is to 24 is to 36, or you can use it as it is. So remember, in maths, if you are sharing, you say 600 over total ratio times the amount you're sharing, 240 over total ratio times the amount, 360 over total ratio times the amount. So let's do that. What's for A? 12,500. 5,000. 7.5. 7.5. So the difference, you then say 12.5 minus the 40. You do that throughout. You do that throughout. So the standard price, what's the standard price? This is the budgeted price. If you go to the budget, you can see those that have not figured it out where the standard price are coming from. These are the standard price of material A, B, and C. So it's 1.1, 2.4, 1.5. Then for the variances, you then multiply. So that's the difference times 1.1. So that's 1,650. So you do that throughout. So these are the variances per unit. Then the total variance, you sum this up. The total variance, you sum this up. So it means overall, we have a material mix variance of 150, and if it's positive, it's favorable. So our material mix variance is 150 favorable. Then from the material mix variance, we move to the material yield. We also have the material yield variance. Or maybe before we get to, but the yield is not affected. You can say the material mix is not affected by loss. If they say there's a normal loss, it doesn't affect. The material mix variance is not affected by normal loss. The material mix is not affected by normal loss. Then we have the material yield variance. We have the material yield variance. So the material yield is more of looking at the output. So the material yield looks at the output. The output that we were targeting against the output we got. So if we change the ratio, it can affect the output. Changing the ratio can also affect the output. Changing the ratio affects the output. So changing the ratio may affect the yield. Hence, the material yield variance compares the output with the budget. So if we had used the old ratio, what could be the output? So if we have changed the ratio, what is the new output? So the columns are almost the same. We just copy that. Let's just copy that. So instead of having the actual quantity standard mix on the first column, we are going to have the actual quantity standard mix on the second column. So we are taking the actual quantity standard mix to the second column. Then the first column is now going to be our budgeted quantity at standard mix. It's no longer actual, it's now budgeted quantity at the standard mix. So the components, we can still use it for the same question we're doing. The components are still A, B, C. A, B, and C. These are still our components. Then the actual quantity standard mix is what you calculated here. So the actual quantity standard mix, because the material yield normally comes after the material mix. The actual quantity standard mix, you take these values. If you are not asked for the material mix, you could just calculate the actual quantity standard mix using what we've done. First of all, get your actual quantity at actual mix. You share it in the standard mix proportions. You get your actual quantity standard mix. What does this mean? This is the actual quantity in the ratio. If we take the actual quantity and we share it in the ratio that we wanted, it's more like what we're looking at when we're flexing the budget to say we are taking the actual results, but we are taking the actual units and saying if we had budgeted for these, it's more like a flexing the budget to say for the budget, if it was applied on the actual units, what would be the budget? So we are saying the actual results, we're sharing them in the ratio of the budget. Now the budgeted quantity standard mix, we are saying what was our budget for these units that we have produced? What was the budget? So for this one, how do you get the budgeted quantity at standard mix? You say, what was the budget per unit times the actual units? Let's go and I show you how you work this one out. So if we come here, this was for 1,000 units. For 1,000 units, we're budgeting that we would use 600 units of A. So we ended up producing 21,000 units. So you can say if 600 units, 600 kgs were for 1,000 units, what about 21,000? So you first of all get the budget per unit, you multiply by 21,000. Or you can use proportion. Can you do that? But if 600 kgs were budgeted for 1,000 units, what about 21,000? Okay, I'm getting 12.6. Is it what you're also getting? 12,600. Mm-hmm. 600 kgs for 1,000 units. What about 21,000 units? 12,600. don't think it all. The 12,600. Can you do the same for B and for C? So for B, we are saying for 1,000, we're budgeting 240. What about 21,000? So I'm sure you're done for B and C. Let's go and slot in the amounts. So for B, 5,040. For C, 7,560. The rest is the same. You get a difference here. So the difference, you're saying this minus this. Do the same throughout. Then your standard price is still the same 1,1, 240 and 1,5. Then from there, we move to the variance. Variance, you multiply the difference times the standard price. So our total material yield variance, you then sum this up. So the variance becomes 296. If it's positive, it's favorable. $296, if it's positive, it's favorable. So now let's move on. So this is the yield variance. So the yield is saying if we change the ratio, is it going to give us a better yield or not? So the other one is on the cost, the other one is on the yield. Then we can have a case where we have a loss. So let's look for an example with a loss. So let's read this one. So I want you to work out the material mix. The mix is not affected by the loss. Can you try to figure out how far you understood? Can you try the material mix? Then we do together the material yield. Okay. So are you done now? I have the answers. Any for the material mix? 20 what? 284 adverse. Wilma, are you done?
Not yet. I'm almost done, sir.
Bridget, are you done? Who else is in? Okay, quickly finish up so that we move. Yeah? Yes.
But nyama yake right.
Which one? Okay, for the sake of time, let's do it together. So we'll start with the material mix variance. For our mix variance, so do we use the first layout? So which components do we have this time around? S1, S2, and S3. Then we start with the actual quantity, actual mix. The actual quantity is used for S1, S2, so we can then sum up. Lisa? Then the same total, we bring it here. We share in the standard mix ratios. Garon sira form re ganongo shibamano no. Form re. So S1, S2, S3. So we now share in the standard mix proportions. So the standard mix proportions is 853. 853. 8. So 853, the total ratio. So we want to share 19,153 in the ratio 853. 853 total, that's 16. So the first one, it would be 8 over 16 times the amount we are sharing. Same goes with the second one, that's 5 over 16 times the amount we are sharing. The last one, it would be 3 over 16 times the amount we are sharing. Let's just round to 1. So the difference, this minus this. Do that throughout. The standard price, it was what? 0.3, 0.5, 0.4. Then for the variance, you then multiply the difference times the standard price. So 284.21, if there's a slight difference, it could be because of rounding off issues. So that's negative 284. In other terms, we are saying that's 284 adverse. So our variance is 284 adverse. Then the second question is the yield variance, but there is a loss. So we have a yield with a 10% loss. So if we are dealing with the yield, we said the yield uses this. Oh. So for the yield, we are using this pro forma. So for the yield, we are using that pro forma. The actual quantity standard mix is not affected by the yield, by the loss. So the actual quantity standard mix, we are just taking the same values we got here. Actual quantity standard mix, we are getting the same quantities we calculated here. But for the budgeted quantities at standard mix, this one is the one that is affected by the loss. The budgeted quantity at standard mix. Let's go to the question. So the question is saying that the actual output was 15,408 kgs. So that is the actual output. So we want that actual output and we flex it to see what would be the actual output before the loss. Because when we are sharing the budgeted quantity, it must be inclusive of the loss. So we are saying if the actual output is 15,408 after removing the 10% loss, before the loss, it would be, you divide by, if 15,408 is after removing 10%, it means this is 90%. So it means you're saying this is equals to 0.9, what about 1? It means you'll be saying it's more. So you divide by 0.9. So you take the actual output, you divide by, if it's, let's say, 10% loss, because the idea is, if the output is now 15,408, and it's after 10% loss, this is now equal to 90%. So we are saying, what is 100% then? So using your proportion, so X is equals to 100%. So using proportion, you can say 90 is equals to this. What about 100%? So it means 100% it would be more. So you'd say 100 over 90 times 15,408. So it will still give you this answer. So you then share the 17,120 in the standard mix proportions. You share it in the standard mix proportions. You share it in the standard mix proportions. What do we get? It's 85. 5350. 3210. Then the rest is now easy. Just say this minus the actual quantity standard mix. Say 5350 minus the actual quantity at standard mix. 3210 minus the actual quantity at standard mix. Then multiply by the standard price, 0.3, 0.5. And 0.4. Then get your variances. So it's 775 adverse. 775 adverse. So 775 adverse, let's leave it here. So I think we've done quite a lot of things. So you can, for now, you can go and polish up what you're discussing. Then, sure, in the next session, we're supposed to finish up the variances. So in the next session, we'll get to the other types of the variances. But variances are very important because they come as section C, carrying a lot of marks. So it's an area where you do need to do thorough justice to. So we have looked at from the list. We are now left with dealing with, yes. So we need planning and operational variances, then sales mix and sales quantity variance. I wouldn't want us to do all of them now because you'd end up mixing up the things and adding more confusion. So go and attempt questions on what you're covering. The next session, we'll finish our planning and operational variances and move to the next. So for those online, thank you so much. Those joining audit will start at 2.